Welcome to my presentation titled, Performance Evaluation of Global Numerical Weather Prediction Models in Tunisia, a Multi-Model Performance Analysis. This presentation is part of the ongoing evolution of our modeling tools at the National Institute of Meteorology of Tunisia, which currently demonstrate high-precision convergence. However, to reach a new milestone in the quality of our products, we must evolve our operational strategy. We will start with an introduction, then we will present the objectives of the study, then the statistical methodology, the thermal and rainfall performance, before focusing on the best choice at the center, introducing the new strategy based on the Weighted Ensemble Forecast, WEF, proposing operational recommendations for 2026, and finally concluding. Our strategy of accessing raw data represents an optimal choice for mobilizing our computing resources to achieve enhanced forecast reliability. Processing data in our own way, tailored to the specificities of the Tunisian climate, lies in our ability to develop our own correction and adaptation algorithms. By shifting from a model production mode to an intelligent processing mode. Our objective is to evaluate the accuracy of numerical models over a 12-month period, to compare raw errors and the quality of trends, to identify the best-performing model by geographic region, north, center, and south, and finally, to establish an ensemble forecasting strategy for the year 2026. The statistical methodology employed here focuses on measuring root mean square error, used to assess the stability and variance of temperature forecasts, mean absolute error, used to determine the actual deviation in rainfall, measured in millimeters, and Pearson correlation coefficient, used to measure the synchronization between model outputs and real-world observations to ensure better trend accuracy. Data scope, a total of 3,934 observations were processed across the year 2025. Thermal performance analysis, our results indicate that the German ICON model is the top performer. Overall performance, all models showed high correlation coefficients, consistently exceeding 0.90, regional highlight. The highest correlation for Tmax, maximum temperature, was observed in the north, reaching an impressive R equals 0.98. The dominance of the IFS model for rainfall forecasting with MAE of 4.89 mm in the north and 2.95 mm in the south, the IFS model showed the best capability in capturing weather disturbances, with a correlation reaching up to 0.62. The ICON model remains the most accurate for central Tunisia, with a MAE of 3.38 mm. Precipitation forecasting remains a major challenge, as correlation coefficients are significantly lower compared to those observed for temperature. In the central zone, the ICON model outperformed all others across all indicators: Tmax, RMSE of 1.22, TMIN, RMSE of 2.35, rainfall, MAE of 3.38 mm. Conclusion: the ICON model is the preferred operational tool for this specific region. The performance study conducted throughout 2025 validates the effectiveness of our current infrastructure and establishes an optimized forecasting strategy. Multi-model approach, adopting an ensemble forecasting strategy is essential to further refining the accuracy of the INM's weather bulletins. ICON model will serve as the primary engine for nighttime thermal monitoring. IFS model will act as the pivot for rainfall dynamics across the northern and southern regions. Operational recommendations, temperature monitoring alerts. The ICON model is our primary reference, specifically for the critical detection of frost events. Flood forecasting, our strategy pivots on the European IFS model, integrated with ICON's rainfall accumulations, to better capture local intensities in the central region. Decision-making framework, model convergence, high confidence. Model divergence, caution/safety scenario. Conclusion: ICON integration. The incorporation of the ICON model in 2025 has significantly refined our results. The weighted ensemble forecasting or the multi-model ensemble, this approach is the key to achieving high-precision weather forecasts. Next steps: automating consensus calculations for daily weather bulletins. Thank you for your attention. I hope this work contributes to a better understanding of ensemble forecasting processes and paves the way for future research. I am now available for any discussions or questions you may have.